You mean something like that, but then standing?
Yes, but on my camera, Tanel looks dead.
Looks? Tanel, smile.
Please.
Oh, you're waiting. Yeah.
Fucking hell. It's
I
so
think
much.
Alex couldn't use also that's for his temporary code. I mean, the test code was hotspot. Probably borrowed some stuff from you. Yeah.
Okay, let's get started. So thanks for coming here, and let's hack something. And by hacking, I don't mean what you usually see from media, that hackers break into systems and steal money or whatever. Hacking really, the original meaning is you just want to know how things work, right? And then use these things for your fun and profit, right? And so basically, this session is about, well, I just do something here. So, I have, as in previous years, the idea is that I don't prepare. So, it's easier on me as well. So, there is no preparation whatsoever. I'll just start showing something. And you can ask questions if you want to. All right. So, this is Oracle 12c. So, in my laptop. And I'll start from some basics, right? So when 12c came out, when I read about this whole containers and pluggable databases and having many different databases in one big SGA, so I immediately thought that, hey, does that mean that I have to rewrite many of my scripts now because we have these containers and this stuff? And it turned out that actually no, because even if you run in this PDB and CDB environment, you still have database processes, you still have database sessions, right? If a user X in container Y or pluggable database Y complains, then you will find out what is the session that this user is using, or what are the sessions that this batch job is using, and you measure these sessions, right? So I don't really do any demos with the CDBs and stuff, but that fundamental part doesn't change. But if you do anything in the database, you will have a session who has a process, and who does some work for it, right? And if something is slow, measure that session, measure that process with Ash, for example, right? So I think I actually may have shown this last year as well, but. So, you see, when that sessions parameter is 472, this just means that we will have 472 session state objects, right? And when I query the $$ view, $$ table under $$ session, I'll see that this is how many $$ session state objects I have, right? And the seed is really the slot number in this array, right? If you have seed number 5, then it means that you are using slot number 5 in the session state object array for your session, right? And so in Oracle 12c, even when you have CDBs and PDBs and whatever things in use, this still applies. You cannot have session number 5 while logged into this PDB, and also somebody else having session number 5 when logged onto this PDB. Because the session state object is like the whole SGA-wide thing, no matter how many PDBs you have in there. So what I'm saying the troubleshooting, the performance troubleshooting really doesn't change in Oracle Cloud State. You know, if you were systematic before that, if you were using the session level approach. So basically, whatever sessions I identify, I can use Ash to drill down into these to see what these sessions are doing, or SQL Trace, or whatever is my favorite tool. So almost all of the performance views have remained pretty much the same. Okay. So the seed is a unique identifier of a session in the whole SGA of the whole container database, you know. So it doesn't really change. All right. So, and let's see. Just for reference, I opened up an Enterprise Manager as well. I have a small benchmark running here. So there is some activity going on here. Well, not that much actually, but I'm going to show you some tools for drilling down into this, right? By the way, this session doesn't even intend to be a useful session. It's just going to show, I want to show you a bunch of different things what you can do with Oracle. Whether you should actually do it or when you should do it, that's up to you, all right? Anyway, so one of my scripts what I use, because I often don't want to log into the Enterprise Manager because it's not there at all, or you know, it's down, or it's too slow, or maybe because I just have my scripts, is something called ashtop, right? And let's say that I want to know what are the top wait events in this whole instance. You know, I'm actually contradicting myself a bit here, so I usually say that you should start from a session of a user, but I'm too lazy for that right now. I just want to know what's going on in the instance. You know, where is time spent in my whole instance? I will explain what these options mean. Okay, so what I just did, I ran a script called ashtop, which just shows me top whatever I've selected from Ash, right? If I'm interested in the top session state and event, wait event, what the sessions in the database are doing, I can do this. And it looks like in the last minute. You see, this is the time from, and this is time, you know, to. That in the last minute in Ash, we, you know, have had sessions. You know, 50% of the database activity has been on CPU. It's actually, I don't have too much activity here. On average, it's less than, on average, it's about half a session on CPU at any point of time within the last minute, right? So I might actually, let me just increase the workload a bit. I'm using swing bench for the benchmark. Let's just use 50 sessions. All right. So Swing Bench is a free Java-based benchmark and data generation tool, which can cause some trouble in your system. All right. So anyway, so apparently I have a bit more I/O going on now. Okay. So if I'm also interested, let's say that you know, I don't care about CPU. Let's say I'm wondering why do we spend so much time on I/O now, okay? Apparently, so let's look into this. So if I want to drill down, it's sort of like clicking on a specific wait event in the UI. If I want to drill down, I can actually, you know, instead of 1 = 1, instead of take all performance data, I can say only show me where the wait event is this. Only take these rows from Ash where wait event is this. I have to put this into double quotes because otherwise SQL Plus would think that, you know, this space means that this guy is the next parameter already. Okay. So you see, now I'm drilling down into this wait event. I'm only reporting this wait event. So let's see. And now maybe I want to drill down deeper. Let's see which SQL ID waits for this wait event the most. Okay, so I have just narrowed down the filter, you know, that only these wait events. And now I'm not doing a group by, the wait event. I'm doing a group by SQL ID. Okay. So this is a script, especially if you don't have a well-working performance GUI available. This script can be really useful for quickly, slicing and dicing through your Ash performance data. Because let me show you what it does. I use these SQL Blast tricks a lot. You see, I'm selecting a bunch of columns, the counts and percentages and whatever, and then I'm selecting at 1. So you see, this is a SQL Blast parameter. So whenever I put SQL ID here, I'm just going to select that column. If I put some other columns here, I'm just going to put these columns instead of this at 1 parameter in SQL Plus. What is AAS? I'll explain it in a moment. But you see, let me get so let me just go a bit deeper here. I'm also doing group by this one. So you see, whatever parameters I pass to the SQL Plus script, that's what I'm going to group by. So it's like passing dynamic group by conditions into your SQL Plus script, right? And at 2, you see, there is an and second parameter, right? You see, first I used 1 equals 1 as a second parameter because I wanted to get all the data from Ash from this date range, right? But now, the moment I replace this second parameter with this will be put into the SQL text, in the script. So now we have added this filter, right? Because I can do other stuff as well. I can say like, or wait class is, I don't know, application, right? So I can add more complex conditions. Apparently not, because I have an outer join here, and so, well, when you have an issue like that, we could just say where regex like event. I don't know whether it will work, but it won't take the wait class. But let's say I want to look into enqueues. Sometimes you can work around this with regex regular expressions. You essentially add an or condition in a regular expression, but again, it must be the same column. Anyway, so that's not what I wanted to show. I wanted to show you that SQL, this script is it's an easy to use script for quickly listing Ash performance data. So what is AAS? AAS means average active sessions. So if in the last minute, right now I'm looking in the last minute here, right? If in the last minute, on average, we had 1.7 sessions who were waiting for this wait event while running this SQL ID, that's when you see average active sessions is this, right? So if you have a single user, a single session who is 100% waiting for something, you would see average active sessions is 1 for that, session, right? If you have more than one session, who all are doing this a bit, this number maybe go higher. So you see the chart you see here. You see the chart goes all the way to 12. This means that on average, around that time, we had 12 sessions who were active. Right? So average active sessions is the most fundamental Ash performance metric. It's sort of like how many sessions or operations you had in progress, right, at that moment. All right, anyway, so I can go deeper. Maybe I only want to look into this query. Okay, let's see what is this query about. It helps to know what this query is, right? It's a select statement. So let's actually drill down into this. I want to see everything what this query is doing. Session, state, event. So now you see I put this into the filter here. Oops. Okay, I want to know what this query was doing in the last last minute, right? And you see, average active sessions is 1.6, which means that there must have been more than one session who were running it at the same time. Well, I can actually add session ID here. You know, if I want to know, okay, don't show me the summary of what this query was doing, but show me the individual sessions. You see, I have a bunch of different sessions who all contributed a little bit to this whole, you know, bigger amount of time, ash time, right? Okay, and you know, usually I don't want to go here today, but usually, if I have identified one session of interest or a few actual session IDs of interest, this is when I run Snapper next. You know, Snapper is again one of my free scripts which doesn't require any changes in the database. And Snapper, in addition to telling of what this session waited for, what this session ran, what this session waited for, it also tells me how many times it did stuff. You know, for example, this column is per second. So this is the total for the 5-second period I ran Snapper. This is per second. So this session executed something 134 times per second. This session had 22 SQLnet round trips between client and server. And you see when I scroll up, you know, they have so many statistics here. This session generated 51 kilobytes of redo per second, right? So I just illustrated you the step number 2, what I usually take when wait events are not enough. I tend to start from ash nowadays. Ash tells me how much you waited, how much time you waited for something. But if I am able to identify some of the session IDs, then I can run Snapper and then see actually how many operations it did. You know, one thing is how long the total time was, but another thing is to know how many times you executed some internal operation. And Snapper will tell you that. Yes? What are these parameters? If you go to my blog and open the script, I actually have like a documentation inside the script itself. But this basically tells me that show me all statistics you can get about this session. This 5 means that run for 5 seconds, so it measures this session right now for 5 seconds. Okay, Snapper cannot go back in time like Ash can, you know. And this 1 means that take only one snapshot. You know, show me only one report. You know, if I had like 10 here, Snapper would run for 50 seconds in total, and it would show this report 10 times. You know, it would measure for another 5 seconds and show the report and so on. And this is the session ID. And if you look into the scripts, you can do stuff like that. If you don't know the session ID, you can say like user is sys or whatever. It can, you know, use other ways to identify the sessions as well. So if you search for Snapper in my blog, you'll see a lot of articles. I even have like a 2-hour video which explains how to use it. Okay, so usually the next question will be here. How come you can wait for something? How come you can be active and do stuff while there is no SQL ID, right? I mean, how can this SQL ID be empty while we are actually doing something?
Session level.
Well, let's see. You know, we can use Ash to drill down into this. All right. So I'm not going to look into this session only. I'm going to look into the whole instance again. You know, if I wanted to look into this session only, then I would just use session ID equals, you know, whatever, you know, in this ashtop. Let's do this. Session state event. By the way, sysdate, this will be put into parameter 3 and 4 in my script. And it's like a between clause where sample time in Ash is between this and that. I don't have to use sysdate. I can use like a timestamp. Let's see. Let's just do date. My time is. You know, as long as you have Ash history, you can go back in time, right? And this is the ANSI SQL syntax of the timestamp. I still have to put it into double quotes because there is this space here, right? it may look a bit complicated, the syntax, but it's simple. It's just that you add double quotes where you have spaces in the parameter. If you have ash history, then you can use this script to go look into past as well. Okay, so let's look into the SQL ID. I'm looking into the whole last hour or so. You see, for example, here we have log file sync where SQL ID is null, right? So let's modify the filter. Let's just drill down into these entries in ash where SQL ID is null. Okay, so now I'm listing only these wait events which were detected by ash where we were actually doing something, not idle, but the SQL ID was null. Okay, so ash has a lot of columns, right? If you do have the licenses for ash, you see 108 columns. If you do have the licenses for ash, then I think one of the biggest favors you can do to yourself is to go through this list of these columns in documentation and kind of, see that you would understand what are they roughly about, because they can be very useful. So for example, let's start from session type. Okay, I added a column called session type here. So now the column breakdown is even done by the session type. So basically you see, I can even remove the SQL ID from the column list because we know it's null because we just filtered it, right? You see, a lot of these wait events are because of background processes. You see, this is DB writer submitting IOs, right? So, DB writer does not need to run some SQL statement just to flash blocks to this, right? So some of this activity in ash has SQL IDs null because these were the background processes who were doing some work without any SQL. So let's just drill down a bit deeper. All right. So I just eliminated the backgrounds. I know that the backgrounds don't use a SQL statement. So let's look into the foregrounds. You see, we have regular foreground processes who still have SQL ID null, but who are doing something. So let's see if we can drill down deeper. Ash has a column called top level call name in 11G. You see, some of these activities here, we didn't have a SQL ID, but some of these wait events are here because we have issued a commit, but we did not send a SQL statement commit to the database. We actually did a direct OPI commit. OCI can issue a function called OCI commit. That will not send a SQL text commit to the database, which will be parsed and whatever. This will just send a special packet saying, I want to commit whatever is in this transaction. So but your session will regardless wait for the commit, right? So that's another case where your session is active, doing something, waiting in this case, but there is no SQL ID. Okay.
And then it could be that you run several statements, so then you commit either way. So you can't attribute log file sync event to a particular statement because you have maybe 3, 5, 10 statements which were
I agree.
updating and so on.
Yeah.
So that's the reason I said it's a session level event.
Yes, and I haven't said otherwise, right? So I'm talking about SQL IDs. I have spoken about SQL IDs and commits, but nowhere I have said, and I hope you haven't gotten otherwise, that you somehow can associate some DML statement with the commit wait event. Commit is a transaction level thing, actually. It's not even, if you have the global two-phase distributed commit, it's actually not even as tied to a session. But it's not directly tied to any single SQL. So what I tried to show here is that I just wanted to kind of remind you that Ash has a lot of very useful columns. If you feel intimidated by the list of these columns here right now, so then take some time and just scroll through it in the documentation so you would know what kind of stuff, what kind of other stuff we have in Ash. So it's Ash is, you know, when 10G came out, it was about like you know, you listed top SQL and top wait event from there, and you didn't have that many other exciting columns there. But times have changed. You know, you can you have columns like in parse, in hard parse. You can even list, you know, from Ash that in which SQL execution phase you are. Are you actually executing SQL, or were you still hard parsing? So I actually have a script called time model. I don't remember what the time model script in Ash, which lists also like in which kind of execution phase you were. Sometimes when you are you know, hard parsing a lot, this will help. Anyway, so I just wanted to remind you that Ash is really a goldmine. If you do have the licenses for that, then you know, that's where I would start. I will start from wait events with Ash. Secondly, I will go to Snapper to find to see what kind of operations are we doing, right? So this was the introduction. So now let's go a bit deeper, right? I don't want to only, you know, go into this deep, undocumented, and not so useful things without reminding you that systematic approach. You know, start from the wait events, top SQL ID, then drill down and all the way, possibly to read or assess that what Snapper uses. Okay. Well, I just have to add, I have to show one more thing about Ash. So earlier I drilled down into a specific SQL, right? Okay, let me just get rid of the session ID. Ash, since 11G, has new columns called SQL plan operation. And let me add SQL plan options. And I'll just put it into double quotes again because this whole thing, because there is a space in here. You see, I have looked into Ash data of this SQL execution only, or this SQL statement only, and I have previously had a breakdown that, hey, we used only 1% of CPU and 99% of time we were waiting for I/O. Thanks to these extra columns in 11G, I will actually see what kind of execution plan line or operation was waiting, right? This is what SQL monitoring report actually uses for showing execution plan line time breakdown, right? And I have a script called ASQL1 for this, which takes the SQL ID, the child number as a parameter, and the time range as well. Okay. This is a frequently executed SQL, right? So let me show you that. See, it's been executed like 700,000 times since I started my benchmark. So this SQL will not be monitored by SQL monitoring, right? SQL monitoring report will show nothing up. But Ash, you know, as we know where SQL monitoring report takes its data from, we can actually report it from Ash. So also for your OLTP queries, you can also report that on which execution plan line you spent most of the time, right? So, but this is not across a single execution of the query like SQL monitoring does. This is across all the executions what we noticed in this time range. So you see, this is how you break down. If something takes too long time, you will identify the top SQL from there. You will identify the top wait events. And you know, in this version, you can actually drill down deeper to see on which execution plan line these waits happen. So you can narrow your, you know, efforts, right? And if that's not enough, you run something like Snapper. Okay, I've spent 30 minutes on the fundamentals, so let's just do something even less useful. There's a question? So how do I know how many seconds we have spent? It's a count star of ash records. You know, ash is like a fact table, right? Ash samples what's going on every second, right? So therefore, the existence of a row in ash means 1 second, right? And then I will just do a group by whatever I want. And this is ash math. This is it works. You know, if you look into ash data over 1 second only, then that's a bad idea. Because whoever happened to do something, you know, they will be shown as the top consumers. But if you look into ash data over the last minute, 5 minutes, an hour, then this 1 second sampling is fine. So it does work, trust me. Oracle guys invented this in 10G and it works. Yeah.
Is this something to do with like data plans?
So does this thing have something to do with the gather plan statistics? Actually, no. I mean, because this is just an example. So there's, this is just a benchmark. I haven't created some optimizer problems here or nothing, you know. But you know, the thing is that when you have a query where execution plan is 300 lines or 500 lines, you would want to know in which section the problem happens, right? Because you know sometimes it's a bit hard to figure out, but sometimes you do see like a union alls, and one of these is taking all the time. So you immediately can know where to focus your efforts. Okay. Anyway, so let's go into let's go on. If you search for these keywords in my blog, then you will find more articles about this stuff. Okay, so let's give something for the hackers as well. All right, so because this stuff is 11G, so you know we don't really need 12C for this. So, all right, let's see what new have we. What new do we have in 12C? So Fritz, this is something for you. So remember, this is not supposed to be useful. So if you don't see where you would use it, then you know it's okay. So in 12C, actually, you know, so basically, let me actually frame it this way: that I have a script called SED which shows all wait events, right? It shows them from with or event name, right? In 12C, in this version, we have 1,600 different wait events, right? And the number just keeps growing. If I show that, SED means show event descriptions, I think. If I show like DB file or something, then you know we'll see this fairly familiar wait events, okay? But what if we see a wait event which name we don't know what it is and nobody knows, okay? I mean, you Google it up and the documentation doesn't show what the heck this wait event is, right? Well, Oracle is a program written in C, right? Oracle is a regular C program. Oracle is a C program. It's a very big C program, but it's a C program, right? Whatever you do in C, that means that some functions must be called, right? So what is a wait event? Wait event really is pretty much a system call that just before making a system call which potentially blocks, Oracle will take a timestamp and say that, hey, I'm waiting for this wait event. And when the system call returns and you get back onto CPU, Oracle will take another timestamp saying that, hey, I'm not waiting for this anymore. And the total time I waited was 5 milliseconds or whatever, right? But in order to do these measurements, this means, again, that some C functions must be called. So whenever you see a new wait event which you don't know what it is, assuming that you are running in a test environment or in an environment where you are happy to run these kinds of commands, you can get Oracle to dump a stack trace when this wait is going on. Because if you end up waiting for wait event X, it means that Oracle has executed some functions which led you to wait for this X, right? So I'll just do this first, and then let's see if you can make sense out of it. Okay, so let's say, I'm just going to take it easy. So let's assume that I want to know what DB file scatter read wait event is. Okay, again, I didn't prepare for this. I'm a bit lazy. But you know, this is a free event here, so you cannot complain. Yeah, I like these kinds of events. All right, so let's enable alter session set. I don't know the correct way in modern days for enabling SQL traces. DBMS monitor session trace enable waits equals true. So this is the modern way since 10G, you know, since like 10 years ago. Okay, and okay, now we only have this trace file, right? So if I do tail minus f here, okay, I just keep these windows like side by side right now. All right, so in before 12c, you could have used dtrace or like GDB, like Fritz has written in his blog, just to use like an OS debugger to get wait event information. But inside Oracle, you can actually do this. Alter session set events trace. Let's see if I remember it off the top of my head. Or no, I don't remember which way it was. So it's just okay, not trace. Wait event. So this is something that has shown up in 12c. So whenever a wait event called db file scattered read ends, then I can attach some command to this, right? So this event will be fired when the wait actually finally ends, right? So, and the command that I want to attach. So this the second part, the first part is 12c only. The second part has been there since 11g, but I only found out about it recently. Let's start from a simple. I'll just say hello, right? So basically, Oracle has pretty since 11g, they sort of re-engineered their whole debug infrastructure. They standardized it and so on. So it's actually pretty powerful. All right, so let's see whether it. So I don't see any hellos here right now because I haven't, caused any of these waits. So let's say if I can use select full t count star from t. Okay, there is no such table as t, so system t. All right. Okay, so I could not reproduce my multi-block reads because the table was big enough compared to the buffer cache, so the direct buf reads kicked in. Well, alter session set serial direct read equals never is when what you would want to do for this test. I mean, and you see, I'm gonna get a bit. I'm gonna you see, let me just show you one thing before I go on. I'm gonna rerun the query. Okay, that just got much more complicated than I assumed because it's 12c. There's something new going on. Let me just add a space here. Okay, so let's just do alter system flush buffer cache. I sure hope that I haven't cached it in the in-memory thingy. So let's try once more. Okay. In-memory segments, yeah, indeed. The table T is in the in-memory. So, okay, sorry about that. So you see how complicated things are. Table T, no in-memory. System T. I didn't want to. I will talk about the in-memory stuff on Thursday, 10:45 in Moscone 104 or something. Okay, so anyway, let's give it one more try. All right, so you see, db file scattered read showed up, and the hello also showed up. Okay, so let me make it a bit nicer. Let me just log out. Let's try once more. So I will add the line feed into the end as well. Okay, let's give it one more try. I gotta go to the different trace file. Let's see which one. And I had to enable the SQL trace as well. So, not this one. Okay. Okay, so let's give it one more try. So where are my, okay, so it's still, yeah. You know, this is what happens when you don't prepare, but anyway. So I disabled serial direct read, but what I wanted to demo, let's just run one more. Okay, it worked, this worked. You see, so this, when the wait event ends, you know, SQL trace prints out a line only when a wait event ends, right? SQL trace does not print anything, any wait lines out when the wait begins, only when it ends. And right after it's done, this processing, it will also print out hello. Okay? And now the last part to add here is that now, instead of printing hello, I want to know which C function led us here to this wait, right? So, and for that, we have a command called so it should go like that. %s, and here I will say short stack. Nope, I have it in my without an underscore. Okay, so what I'm doing now is that whenever you hit this wait event, print out also the short stack trace of the C function calls, what led us here. All right, and let's just do this again. You see, it's actually slower now because every time it has to do a stack back trace, which is not, you know, completely cheap operation. And you see, there's a bunch of outputs here. Let me just go to VI and format it. Okay, so the last time this wait event ended, maybe something up here. So when this wait event ended, Oracle also printed out the short stack, right? You see, it usually stack traces are, you know, they're like, I don't know, the functions are on top of each other, line by line. But in here, Oracle has put an arrow that, you know, that this particular function called this function, who then called that function. So VI is really simple. I will say substitute, wherever I have this arrow, substitute it with Control V, Control M. Did you follow me? And globally, right? So this just converts the stack trace into this more readable standard representation. And apparently, some of this stuff has been truncated because I guess Oracle didn't print out or walk back all the way to the main function. Normally, you would see main function where it starts from. Yep.
Do you need SQL trace to be enabled for that, or can you do it without SQL trace and it just creates a new trace and when that happens?
So the question is, do you need SQL trace to enable this behavior? No, you can actually dump this output without SQL trace. But right now it's nice and easy. I see what wait event it is and where the stack trace came, what the stack trace was. Because when you want to trace all wait events, right? I haven't found yet how to print the wait event name from this mechanism. But combined with SQL trace, it will tell you, because the output immediately following this line is what this was for. And basically from here you would see, so this is the wait end function, and the one who called this, the one who caused this wait event is ksfd.io. KSFD is some kernel service file disk.io, right? So. And I don't want to go deep in here how to translate this, but well, actually, I will end up doing that. So yeah, but the first thing is Google it. Too many results, too much crap. Go to Metalink, MyOracle support, search for a couple of these top functions. Put the top 5 functions in. If they don't return anything, then just put each function one by one in. And search through bug descriptions and so on. And sometimes some Oracle kernel engineers have explained what these functions mean, when they've had crashes there and so on. But anyway, from here we see that we are doing some table scan, and eventually it looks like it has something to do with reading, issuing IOs. Okay. So there used to be an awesome Metalink note which documented not all the function names, because Oracle has 300,000 functions or something like that. In the C part, and but there used to be a document which described what these beginnings mean, because the first 3 characters, they usually tell you from which kernel module this function came from. You know, KCB, what Kevin Claesson mentioned yesterday, that's kernel cache buffer. You know, it's the buffer cache related function. So we were doing the buffer read, right? So sometimes you don't even need to know what this function name means. It's good enough to know what the beginning first 3 characters of this function name mean. This MetaLink node has been taken off MetaLink. There are still helpful Chinese and Russian websites where it's cached, right? So sometimes, you know, you search for the function name or the prefix, you know, take a couple of these prefixes and add like a search string that only show me Chinese websites, then you will, you know, find what you want. However, starting from Oracle 11g, you can say Aura debug doc. You know, Aura debug help has been there for a long time, but Aura debug doc is something new in 11g. Aura debug top component tells you all the Oracle modules which are traceable, you know, at least in theory. The trace hasn't been implemented for all of them. So you see, so then I can search backwards. KSF, for example, what is KSFD? KSF. So for example, so these are all the modules which you can actually trace. But this is like KSFM. If you see something like that, it means kernel service file mapping. It's, you know, it has something to do with files. So you see, you scroll up, there are lots of modules, and you see this is the module name, right? So whenever you see a function name which prefix you don't recognize, you can run Aura debug doc. You know, you can Google, and if you still don't find anything, you can run Aura debug doc and search for, you know, these are the module names, which sometimes have explanation what they are. So for example, in memory, okay, I am. Let's search for memory. Let me try another database. Sorry, I am a bit stupid because this is Oracle 11. Don't have that there yet, so that's. It always helps, you know, when you troubleshoot something, it always helps to be logged onto the right database. You know? I've learned it, you know, many times. So, all right, so Aura debug doc component. You know, we have much more stuff here, but if I search for IM, for example, you see, this is what Riyaj mentioned yesterday. You know, you can trace all this kind of different in-memory components. So this is the component name, and these are the sub-modules under it. You see, even the function name prefixes are there. So whenever you see a crash or Aura 600 in, you know, KTMSJ, you'll see it has something to do with in-memory transactional shared show notes. And you can actually trace the whole thing. You'll set, you know, trace IM star, right? You know, you don't even have to list them individually. Just say trace all set events. You know, trace all the sub-components under the in-memory, right? So, so anyways, this is how you know, can find out what these functions mean. But the cool thing is that, you see, back to here, you know, at least you know where it comes from. You know, you might not know what these function names mean, but at least you are already halfway there because you know which functions are related. So now you at least know which function names you have to somehow figure out, you know, call your friendly Oracle guy or something like that. So this was about kind of manually drilling down deeper. So let's just do one more thing. Let me just say, I gotta log in back to the, okay, so one thing what I forgot. So you see, you can say all here as well, right? You see, I have set the trace all wait events, right? And together with SQL trace, I can see what's going on. So let's say create table space X, whatever. So the file size 1. Okay, I'm not an ASM, so okay, I'm just lazy, so let's just do this. It's not that fast because it's tracing a lot. Yeah. Let's see what weight events we'll find from here. So I just want to do like alter, create a new table space or so, and then that will create a lot of different weight events. So let's see what weights we have. Do we have anything cool? It's just sequential reads. Well, maybe this, disk file operations IO, what the heck is this, right? So, disk file operations IO, this is the weight event, and now let's just change this arrows to line feeds, okay? Apparently, again, the output was truncated, you see, not everything, normally the stack starts from the main, right? Or there's another special function as well, but apparently, what the heck, that KSFT share, maybe it's cloning a file descriptor or something like that. Sometimes Oracle opens a file and then it clones the file descriptor to another file descriptor and closes the original one for whatever reason, right? But at least it looks like, so there's a function called KSFT share, sharing something, I suspect, file descriptors. And when you combine it with the strace output, so you will actually see the system calls that Oracle makes. That's that will probably give you the full picture. Okay. Okay, I have a few minutes left. So this is like how you can drill down into weight events. I'm not, what if you have CPU usage? What if 100% of your problematic sessions time goes on CPU? Well, then you have to run a CPU profiler, like perf or dtrace or something like that. So, and it will tell you, well, actually, let me just show you that. I'm gonna run one of my lots of hard parses. It's a loop which does a lot of hard parses, right? My session ID is 35 here. So let's say if I say I can run snapper. I could use ash as well, but we are out of time, so I'll just go to snapper straight away. So I'm just measuring what this session 35 was doing, or in the last 5 seconds. Something is wrong. So 5 seconds have passed already, right? So this is a chance to actually practice what I preach. Snapper is supposed to be completed by now, but it's not. So will I restart the instance? No, I will figure out why it's so slow, but now it's actually faster again. That's weird. Let me just log into. I think I've overloaded the system. Maybe there's
still running too.
Your swing benches, probably.
Yeah, swing bench is running as well, but it handled it okay. So I see the session is 258, 258. Snapper itself is, let's see, it's Linux 121, 121, I'm in the right. The trace should not be still on. So this is totally weird because, Snapper, it should not be reading stuff from memory. Yes, it will occasionally sleep. That's how it's designed. I can actually see what this SQL ID is. Okay, so I think Snapper's GV query has gotten a bad plan or something, and it ended up looping through something. So this will be a Snapper tuning exercise. But anyway, Snapper ran too slowly, but it finally figured out what my other session was doing. Okay, one more reason why, I had a hard parse loop, right? I created a hard parse loop, which caused share pool issues, which probably made the buffer cache to be shrunken smaller because we needed more memory in share pool. But anyway, so if you see the other session, what I measured, it's been on CPU, most of its time on CPU, running different things. when I see somebody using a lot of CPU, I would want to know how many hard parses this guy is doing, how many logical IOs it's doing, and Snapper answers all of these questions. This guy was doing 400 hard parses per second, but if that's not enough, you don't see any hard parses, you don't see anything showing up in here. It's not, maybe you're spinning somewhere because of a bug. Well, if CPU is your problem, then you can drill down further with an OS level CPU profiler, for example. You can actually use Aura debug as well with that. I suspect that my benchmark has, or my loop has caused a lot of, I cannot know from here, but symptoms look like it's probably paging a lot, because when I cannot even SSH in, well, VMstat would confirm that. Nope, not that much. Anyway, so I was wrong. But let's now finally pick this problematic session. So this is the guy whom I want to measure, because this guy is using a lot of CPU. Well, let's use SPID is this. Perf top minus P. So that's the simplest version. Let me just go back. So I'm using perf, which samples what this Oracle process is doing when it's on CPU. Perf doesn't sample weight, but only when you're on CPU. And you see, again, we are getting a whole bunch of functions which are the top CPU consumers. KGH ALF is kernel generic heap allocate freeable memory or something like that. So we're spending a lot of time searching, through linked lists and shared code like it. Again, I don't intend to actually explain all of them, but I'm just telling you that there is a way to go deeper, right? So the next time you see an issue, you have tried all the means like Snapper, SQL trace, Ash, and so on, and you still don't see why the heck this process is burning 100% of CPU. Well, you gotta use a profiler which tells you in which C function you are. On Linux, you can use perf. On Solaris, you can use dtrace and so on. Okay, any questions? Yes?
In your previous example, you had table cached in memory segments.
I had a table cached in
memory.
Yeah,
you had in memory. But you still had the serial direct read on it.
So yeah, for some reason I still saw serial direct reads. I mean, I saw them the first time though. So I had rebooted my instance. The table was marked as in memory with no priority. And I had restarted my instance. So when I started my demo, the first time I ran a query against the table, I got serial direct reads because it was big enough. And thanks to that, thanks to the first access, the background process woke up and populated. While I was talking, it populated this table in memory. So that's why the next runs didn't show any wait events. I will be around here just outside if you have any more questions. So I will still have 1 minute to go, I guess. I will close down my things here. Thank you very much.